Alright guys, welcome to the video notes for, this is technically 1.3. We're doing slope for this one, also known as rate of change. So these notes should be about a 15-minute video here. And you see, so we got the first kind of bit of stuff written up here. So, slope, we kind of call it rate of change. And then, so basically rate of change and slope, we kind of, if you're asking what's the rate of change? Basically what it's wanting you to do is find the slope, and it's kind of similar problems there. And then here's some kind of things, a lot of us know slope, rise over run, how much you go up or down over how much you go left or right, and then equals, and I kind of put like change in y kind of by this little triangle here. They usually denote that as a change. So change in y over change in x, and then kind of your basic formula right here. Y2 minus y1 is equal to x2 minus x1. And we'll kind of show you how to use that formula there. So different types of slope, when you do lines, you really only have, a line can look these four different types of ways. You have a positive slope, starts on the bottom on the left, goes up as you go right, and then negative slope, which is kind of the opposite, starts up on the left, goes down as you go right. A zero slope is just straight across here. I also call zero slopes kind of no rise, a no rise slope. It just goes straight. I know this one kind of has a little bit of an angle to it, but it basically is a slope that's straight horizontal line. And then undefined is something like this. Now, you can't really read it on the bottom here, but it actually says 0 on the bottom of the fraction. So basically, again, slope is basically like a fraction, number over number. If your number on the bottom is 0, then you know that your slope is going to look like this, okay? So again, these are the four different types of slope that we're going to use, and actually knowing what a positive and negative slope looks like helps us out with a few questions, especially these questions right here. So we want to find the slope of each of these graphs. So what I'm going to do here is I'm going to pick out 2 points, and just for simplicity's sake, I could just pick out these points right here. The points that they give us, and I'll pick those 2 points out right there. And essentially what I'm going to do is I'm going to count the number of times, the number of spaces I have to go up to meet this point. So I have to count up 1, 2, 3, 4, 5 spaces. So I counted up 5. And then I got to count the however many spaces I count over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 is my rise. That's the amount I go up. So it's going to be 5 over 10. And you simplify that fraction, 1 over 2. And look at the slope. Starts down, goes up. That's a positive slope, so you just leave it as positive 1 over 2. If you go to this one right here, we'll just use these endpoints here. Same idea. I'm going to count. I have to count down here, so I got to count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 10, and then over 1, 2, 3, 4, 5. Over 5. So I went down 10, left, or right, technically 5. It's a negative slope, starts up here and goes down. Technically, if you count down 10, it's also a negative 10, so it's going to be a negative slope. And just as we did over here, you simplify that fraction, it will be negative 2 over 1, or you could even just write out negative 2 for that. Now we find the slope between the pair of each points. Now this is where we're going to use this formula. Okay, so we're given a pair of points here, and basically what we're wanting to do is we're going to find the slope between each of those points. And what we're going to do is we're going to use the formula that I kind of put on the first slide there. It's y2 minus y1 over x2 minus x1. Well, how do we get these points here? Well, these are x values right here, and these are y values. And all I have to do is, well, let's say this is my first point. This will be x1, this will be y1, this will be x2, this will be y2. And so, what I got to do, just plug the numbers into my formula there. So y2 minus y1, for that'll be 14 minus 4 on top of the fraction, and then on the bottom of the fraction, I'm going to do x2 minus x1, which is going to be 21 minus 3. Then if you basically subtract those out, you get 10 over 21 minus 33 is 18. Simplify that fraction down, and then you get 5 over 9, okay? And it's the same thing for this one here. You know, you just set up your points, x1, y1, x2, y2, and then set up your slope formula. So you do y2 minus y1, which is negative 2 minus a negative 2. Make sure you remember that negative 2. Get a lot of people that mess that up. That'll just turn into a positive. And then x2 minus x1, which is 7 minus 4. Negative 2 minus a negative 2, which is the same as negative 2 plus 2, is 0 over 3, which means your slope basically is just 0 there. 0, okay? So again, that's your slope formula right there. And I think, yeah, this one was kind of having a little bit of trouble showing it, so let me kind of go here. So we'll go to this part. So we have parallel lines. Now the slideshow wasn't showing this, so I kind of had to exit out of this. So parallel lines, oh, back up a little bit. So basically talking about parallel perpendicular lines. Parallel lines are essentially lines that have the same exact slope. I mean, we all know about parallel lines. The two lines that are just never going to touch, do not intersect. What that means is that they're going to have the exact same, basically, slope, so to speak. And then perpendicular lines, what they're going to have is what we call the negative reciprocal. So basically, if you have a slope, let's say of 2, slope of 2, you're going to have the negative reciprocal is going to be negative 1 over 2. And same thing, if it's, you know, slope of 3 over 5, the perpendicular slope is going to be negative 5 over 3. You just reciprocal, you just flip that fraction around, okay? So then, all right, so that's kind of where we're at, so perpendicular, parallel. So let's go to this one right here, and is it not going to show us? Oh, it is going to show us, so you just got to click through it. I guess that's what my situation was. Okay, so this one, it tells us that it's perpendicular, but let's go ahead and prove it. I'm going to use purple for this one. So you got line 1, which passes through those 2 points right here, and then line 2 that passes through these points right here. And we basically need to do is, well, find the slope of each of those lines. So for line 1, I got y2 minus y1 on the top, which for line 1, that would be v, so I'd do 5 minus a negative 1. And then on the bottom, you do x2 minus x1, which would be 2 minus a negative 3. Add all those up, basically, minus a negative is a positive, so you get 6 over 5 for the first one, for the slope of line 1. And then it's the same process for this one. Your y1 is negative 4, y2 is 1. Let's go ahead and set that up. 1 minus a negative 4. And then x2 and x1, you're going to have negative 3 minus 3. Minus a negative is positive, so 1 plus 4 gets you 5. Negative 3 minus 3 gets you a negative 6. Overall, that will get you negative 5 over 6. And then remember, that tells us that the lines are indeed perpendicular because the first line is 6 over 5. 5 over 6 is the reciprocal with a negative, so you have the negative reciprocal. So it is indeed perpendicular. Okay? And then I think this is the last, yep, this will be the last problem that we work out here. So basically, we're trying to find the rate of change on this. And again, rate of change, same exact thing as the slope. All right, that's the exact same thing that I'm finding is the slope. So what I'm going to do is I'm going to basically treat these, you know, like kind of data points, like ordered pairs, and basically use the slope formula. So generally, if you're given time, so like 2 hours, that's a measurement of time. Dang it, I keep going forward. Normally, we denote time as x. So my other point for time is 6 hours. That's also going to be another x. And normally, my altitude or height, we usually denote that as a y. So anytime that you're dealing with, like, you know, height or, you know, kind of distance, you normally denote that as a y, and you normally denote time as x. So basically, if we set up them as ordered pairs, 2 hours denotes with 400. So I'd have an ordered pair 2, 2 with 400, and then 6 with 700. basically I have two ordered pairs right there. And then all I got to do is use the slope formula. I have y2 minus y1 over x2 minus x1. Set that up. I'll choose my y2 as 700, my y1 as 400. So I have 700 minus 400 over, and then x2, x1, 6 minus 2. I'm left with 300 over 4. And if you simplify that down, you should, I believe, you would get 75 over 1. And again, if I'm dealing with rate of change, normally I try to deal with, units here. That basically tells me I'm dealing with 75 feet per hour. So every hour I'm climbing basically 75 feet. Okay, so that's basically what my rate of change there is. Okay, so that is it for 1.3 rate of change and slope. Please let me guys know if you have any questions, and I'll keep you on the lookout for the next videos. Thank you.